Hello. Thought I'd try to help you with percent of water in a hydrate. First, just a little review of percent. Percent's always part over a whole. Like if a whole class was 25 students and 8 of them were boys, then the percent of boys in the class then would be 32%. And the percent of the girls in the class would be 1725, which would be 68%. So percent is always part over whole. And we're going to apply that to this lab we're doing with the hydrate. And we'll use this hydrate here, which is epsom salts. Epsom salts is, its name is magnesium sulfate heptahydrate, okay? And it's commonly used to soak injuries in, and also it's also a saline laxative for short-term relief of constipation. Well, hope you don't need that. But let's take a look at this. So let's say that my dish here, I got a dish. Let's say that weighs, we'll say 30 grams. Okay, 30 grams for the dish. And I put in some Epsom salts. Let's see. And then I weigh it. Now it weighs 40 grams. Okay. Now I cook it, heat it, get all the water out until it looks like this. There you go. There it is. And I weigh it. And now it weighs 35 grams. The stuff that's left is called anhydrous salt. It's a hydrate with the water taken out. Okay, so now it's pretty easy to see that I could do some subtractions and find out different amounts. For example, the amount of hydrate would be the difference between these two. I used 10 grams of hydrate, right? So I used 10 grams of hydrate. And if I wanted to find out how much water there was, I could subtract these two, because between here and here, I took out the water, and that would be 5 grams of water. That'd be 5 grams of water. So I got 5 grams of water. Okay. Now, I'm just kind of got off the board here a little bit, but here, I'll just transfer it over here. So I got 5 grams of water over 10 grams of hydrate. And so that means this hydrate is 50% water. The hydrate is 50% water. And that would be my experimental value. Okay? That's what I got from the lab data. Now, I could figure out how much water there is theoretically in this just by doing a simple calculation from the formula. I could take the magnesium sulfate, okay, plus 2, minus 2, so it's MgSO4, and it's heptahydrate. Hepta means 7. I could add all this up, 24, 32, and 4/16, and I would get 120. And each water's 18. 7 times 18 is 126. So altogether, this is 246. So the molar mass of the hydrate is 246 grams per mole. Okay, now how much of that is water? Well, I'm thinking you can see now that the water is going to be, so we'll put the water over the hydrate. The water part is 126 over 246. Okay, and if you divide that and multiply by 100, you're going to get about, that means about 51%. So that would be called the actual percent of water in the hydrate. That would be called the actual percent water in the hydrate. Now we could find the percent air by using this number right here, which is the actual percent, and then what we got previously from our data, which was 50%. So let's do that now. Okay, so percent air is experimental minus accepted all over accepted. And you have to do the subtraction first. You have to tell your calculator to subtract first before you divide, or it won't do it. And then once you get that number, you multiply by 100 to make it a percent. Okay, so here we're going to have, we had 50, and then 51 was the accepted value all over 51, okay, which is going to be approximately 2% air, okay, when you do the math. So that is how you do this lab with percent of water in a hydrate. I hope that helps.